Good morning to you all. Today we are going to learn about the hydrostatic pressure and its applications. Okay. From this heading, you can anticipate there is another type of hydraulic pressure. Here the heading is not mentioned as hydraulic pressure. Okay. So we can anticipate another type of pressure also available. Yes, actually the hydraulic pressure has two types. That is, first one is the hydrostatic pressure and second one is the hydrodynamic pressure. Okay, the hydrostatic pressure means we all know static is a stable condition. If if the fluid is at rest state, if the pressure is exerted, we called it as hydrostatic pressure. Clear? Hydrostatic means that here fluid is at rest state. Okay. Then move to the hydrodynamic pressure. In these conditions, if the pressure is exerted, when the fluid is in motion, we call it as hydrodynamic pressure. Anyhow, up to our level, we don't bother about the hydrodynamic pressure. Okay? We have to concentrate only for the hydrostatic pressure. Okay? Hydrostatic pressure is enough for our level. Okay? So, we are going to learn about the pressure that is exerted by the fluid when the fluid is at stable state, or the rest state. Okay? In this unit, we have to learn these chapters. That is, first one is pressure. That is actually a recall session. You have already studied. That is pressure exerted by the solid substance. Okay, you have studied this one already. And second one is the new topic, that is hydrostatic pressure. And third one is the transmission of pressure through liquids. How the pressure is transmitted through liquids. We have to learn this also. And fourth one is the pressure due to the gases. And fifth one is fluctuations. We can notice here we are going to learn about the hydrostatic pressure and pressure due to the gases. Okay. Actually, the liquid substances and gas substances all together is called as fluid. Okay, in Tamil it's called as pi. So here we are going to learn about the fluid pressure exerted by the particles. Okay, actually the pressure exerted by the solid substances is slightly differ from the fluid particles. So we categorize those liquid particles and gas particles all together as fluid. So we are going to learn in this session as the fluid pressure. Okay, clear? Thereafter we have to learn about the fluctuations. These are the chapters we have to learn in this unit. Okay. Now before move to the hydrostatic pressure, we have recalled what we have studied up to now regarding the pressure exerted by the solid substances. You have already studied that the pressure exerted by the solid particles. Okay. I have a brainstorming question for you. Consider two cases. Okay. In case one, a girl is wearing sneakers. Sneakers means that's the flat shoe. A girl is wearing sneakers on Monday and you are sitting on a bench reading newspaper. She starts jogging and accidentally puts her steps on your foot. Okay, that is the case one. A girl is wearing sneakers, that's the flat shoe, and accidentally puts her steps on your foot. That is the first case. A second case is the same girl, but here she wearing a heels. That's the pointed shoe. She wearing a pointed shoe. In Tuesday, same situation, that is you are sitting on a bench reading newspaper. She starts walking and accidentally steps on your foot. Okay, clear? Clear two cases. The case one, a girl wearing a sneakers, that is the flat shoe. Second one, same girl wearing heels. What is the difference between two cases? Only difference is area of the force applied. Same girl, so force is similar. My question is, in which case you feel more pain? In case 1 or case 2, you feel more pain. In both cases, force applied by this girl is same. It may be a 500 Newton. In both cases, force is similar, same, but what's the difference between two cases? Only difference is the area of the force applied. In the case 1, 500 Newton force is applied or distributed throughout all of this area. But in case 2, this 500 Newton is pointed on this little area. So you feel more pain in case 2. So now you can recall that the pressure is a factor that can be affected by the force as well as the area of the force applied. Okay. Now we move to the pressure. Actually, pressure, what is pressure? Pressure is a perpendicular force. That's the important term. That's the perpendicular force. If the force is applied other than other areas, that's if in the solid particles, if force is applied like this or like this, there's no change in the pressure. Only the force affecting in the perpendicular to the area is only affect the pressure. So, we can define the term pressure as a perpendicular force acting per unit area. So, in this condition, we can say we don't need to bother about all the area of the particles. Only we are concentrating this area, that is the perpendicular force acting area. So here we define the area also. Are clear? Now, we don't bother about the all the area of the particles. Only we have to concentrate that the area, that the perpendicular force acting area. So pressure is the perpendicular force acting per unit area, we can call as pressure. Okay. So pressure is equal to force upon area. So we all know the unit of force is Newton and area for unit for area is meter square. So the pressure unit for the pressure become as Newton meter minus 2. Here you have to concentrate that here I have write it as Newton in capital letter but meter in small letter. That's the important things. Now you may have doubt. In some cases, we denote as capital letter, but in some cases we denote as small letter. If you think about kilogram, in kilogram we write in both cases as small, K and G also small. But in Newton meter minus 2, we write it as Newton in capital letter and meter in small letter. What's the difference? Why we differently write both cases? Actually, if the unit is named after a person, okay, if we denote the unit as a person, the symbol is capitalized, okay, and also if other examples for these type of units are Newton capital A. Likewise, Pascal, Joule, that's are these some examples. Okay, are you clear? If the unit is named after a person, a scientist who discovered this factor. If the unit is named after a person, we give a capital symbol. Okay, so we give Newton N for capital and meter for small letters. Okay, Anyhow, if the even the unit for the pressure is Newton meter minus 2, SI unit for the pressure is Pascal. It's actually a tribute to French scientist Blaise Pascal. Okay, who is this Blaise Pascal? Is the person who discovered the Pascal law. What is Pascal law? Pascal law is if a pressure change in one point is transmitted without loss to every portion of the liquid and to the whole of the container. That's the Pascal law. Okay. As a tribute to French scientist Blaise Pascal, we give SI unit for the pressure as Pascal. Here, P should be capital and A should be small. Okay. That's the SI unit for the pascals. Actually, 1 Pascal is equal to 1 Newton meter minus 2. Okay. So, now we have studied that the pressure is a perpendicular force acting in a unit area. Perpendicular force acting in a unit area is the pressure. Unit for the pressure is Newton meter minus 2. Anyhow, SI unit for the pressure is Pascal. Is actually a tribute to the scientist. Okay, are you clear? These things are you have already studied. It's a brainstorming part. Now we move to our. There are some exercises for you. The force exerted by a weight of person is 600 Newton. Okay, 600 Newton force is exerted by this person. The person is in a different position as when standing. This area is given, like sitting also area is given. You have to ask, find the pressure in each situation. Okay, first conditions, force is given as 600 Newton, area is given as 0.05 meters square. Okay, we know pressure is equal to, you have to write each and everything with formula for the pressure. In the exam point of view, we give 1 marks for this formula. So, pressure is equal to force upon area. So, you have to write each and every term. Force is given as how much? Force is 600 Newton. How much area? Area is given as 0.05 meters square. Okay, 0.05 meters square. You have to simplify this. For easiness of simplification, I multiply both cases into 100. For 600 into 100, when we multiply 0.05 with 100, it becomes as 5. So, 5 Newton is meter square. So, answer is 12,000 Newton meter minus 2. Okay, Newton, this meter square in down portions, when come to upper portion, it become as meter minus 2. So, we can say in first case, the pressure exerted by the person at when he is standing, the pressure become 12,000 Newton meter minus 2. It's equal to 12,000 Pascal. Okay, P should be capital and A should be small. Okay, 12,000 Pascal. Okay, okay. Now you see the second case. When the person is at the sitting, area is given as 0.1 meter square. So here also you have to write the formula for the pressure. Pressure is equal to, you have to write in full. Pressure is equal to force upon area. Pressure is equal to force upon area. Force is given as 600 Newton. 600 Newton. area 0.1 meter square. So easiness, I will multiply both cases into 10. Okay, 10. So you will get 6,000 Newton meter minus 2. Okay, it's equal to 6,000 Pascal. Okay, I clear 6,000 Pascal. So in this conditions, the answer is 6,000 Pascal. Okay, next move to the other condition. Here the area is given as 0.4 meters square. Okay, so pressure is equal to force upon area. You have to write full formula. Okay, force upon area. Force is 600 Newton. Area is 0.4 meters square. So for easiness of simplification, I multiply both cases into 10. Okay, both cases into 10. So upper case become as 6,000 Newton and lower portion become as 4 meters square. Okay, if we simplify this, you will get 1,500 Newton meter square. When come to upper portion, it become as minus 2. So 1,500 Newton meter minus 2. So it's actually 1,500 Pascal. I clear? Same person having weight of 600 Newton. Okay, but when there is a in different position, the pressure exerted by that person is varies. When he is standing, the area is smaller one, so he exert more pressure. And when lying down, the area become large, so the pressure become low. Okay. Then now we move to the other question. A pressure of 20,000 Pascal is applied on a floor with an area of 0.2 meters square. The question is, what is the force produced? Okay, we know pressure is equal to, you have to write the full formula. Okay, pressure is equal to force upon area. Actually, this type of question, in exam point of view, they give 3 marks for these questions. If you write the formula, you will get 1 marks. And for the substitution of this value in this formula, you will get 1 mark. And another 1 mark is the final answer with unit. That's the must. Without unit, you can't get these 1 marks. So after if we substitute this value, pressure is 2000 Pascal. Pressure is given as 2000 and force is given as force you have to find force upon area 0.2 meter square. Okay, this is Newton meter minus 2. Okay, if we substitute this value in the formula, you will get 1 marks. Okay, then multiply both cases, we get 2000 into 0.2, you will get 400 Newton meter minus 2 into meter square. Both cases are cancelled out since the base of both cases is same. So these two cases will be cancelled out. So you will get the answer of 400 Newton. So force applied by the force applied is 400 Newton. So answer is 400 Newton. So in this case, pressure is given and area is given. Asked to find the force. Okay, this is also one type of question. And another question. A butcher uses a knife. Okay, a butcher uses a knife with a surface area of 0.2 meters square. Okay, here surface area given 0.2 meters square to cut a piece of meat. Okay, if the butcher uses 20 Newton, so force also given, area also given. The question is, what is the pressure produced? Okay, so we know the formula for the pressure. Pressure is equal to force upon area. Force is given as 20 Newton and area is given as 0.2 meters square. Newton meter square. So the answer becomes as 100 Newton meter minus 2. You can simplify this, okay? 20 into 10 over 0.2 into 10. For the easiness of simplification, I multiply both cases into 10. Okay? So, it's become as 200 upon 2. So, answer will be as 100 Newton meter minus 2. Are you clear? And another question is given. Question is a girl weighing 60 kilogram. Here notice, here given the mass only, not the force. Mass is given as 60 kilogram. Wearing high heel shoes, stabilize herself on a single heel. Okay, he stabilized on a single heel. Area of the heel also given as, area is given as 0.002 meters square. Okay, the question is calculate the pressure applied by the heel on the horizontal floor. Okay, here force not given, given factor is mass. So we all know to find out the force, we have to multiply mass into gravitational acceleration. So gravitational acceleration, for our easy calculation, we normally assume the value of gravitational acceleration as 10 meter second minus 2. Okay, so mass is given as 60 kilogram and G is given as 10 meter second minus 2. So answer become as 600 kilogram meter second minus 2. We all know that kilogram meter second minus 2. 1 kilogram meter second minus 2 is equal to 1 Newton. So its answer become as 600 Newton. Okay, clear? So now we substitute in our formula that the pressure is equal to force upon area. You have to write full formula. Force is given as 600 Newton. Okay, force is given as 600 Newton and area is given, that is 0.002 meters square. So, for the simplifications, I multiply both cases by 1000. So, 600 into 1000 Newton over 0.002 into 1000 meters square. So, answer become as 60,000 upon 60,000. Sorry, 600,000 Newton upon 2 meters square. So, you will get answer of 300,000 Newton meter minus 2 of Pascal. Clear? These are the some exercises for you. Now we move our topic, that is hydrostatic pressure. Okay. When we place a solid object, that's a solid object on a table. pressure is exerted by these solid substances on the table due to the force applied by these solid substance on the table. I clear? We have studied that, see, if a solid substance is kept in a table or force is exerted, pressure is exerted by this solid substance on the table. Why? Due to the weight of these solid particle or solid substance, a force will be act on the table. So we already studied pressure is equal to force upon area. So if a force is applied, a perpendicular force is applied on an area, and ultimately the pressure will be created. So this is the fact we have studied. Let's see. Due to the weight of the solid particle, a pressure is exerted on the table. Okay. Similar situations will happen for the liquid particles also. Okay, if a container having the water column of height of h, okay, we assume a container have water column having height of h. Here in the bottom of the container, there is a pressure is exerted. Why this pressure is exerted? Due to the weight of this water column. Okay, due to this weight of the water column, pressure will created in the bottom of the container. Okay, same situations for the solid particles. Pressure is exerted due to this weight of these solid particles. Likewise, for the liquid particles also, due to the weight of these liquid particles, the pressure will exerted. Okay. When we move to the direction of the hydraulic pressure. Okay. What about the direction of the hydraulic pressure? Actually, the solid particles slightly differ with the fluid particles. In the solid particles, the molecules are arranged as compactly. So, the random movement of these particles is limited in the solid particles. But in the fluid particles, the the particles are loosely bounded. So, loosely connected particles in the fluid substances are going to move randomly. So, these solid particles, these fluid particles are connected loosely. So, they are going to move randomly. So, if the random move particles, if bump with any particles present in the liquid or with the whole of the container, they are going to bump. These random moving particles going to bump with the objects present in the liquid or with the whole of the container. Okay, both cases are possible. If we kept any solid particles within the liquid or in the whole of the container, these random moving particles are going to bump with the objects present within the liquid or with the whole of the container. So, the force will be exerted. During the bump with the other objects, there's a force will be exerted. So, the pressure is generated. You can notice the arrow points here. The arrow points, you can notice the arrow point is in all directions. So, we can say the hydraulic pressure act in all directions. Okay. So, now we have studied as water pressure is generated by two ways. Okay. We have studied solid pressure is generated due to the weight of the solid particles. Okay. Weight of the solid particles. But in case of water pressure, it's slightly different. Here, the molecules are loosely connected in the water body, bottom on water, the molecules are loosely connected. But in the solid substances, these molecules are compactly connected. So there is no random movements in the solid substance. But in the fluid or water, the particles are loosely connected. So they are going to move randomly. So two ways water pressure will be generated in the water liquid substances. First one is due to the weight of the water column. That is similar to the solid particles. Okay, the pressure generated by the solid substance is samely due to the weight of the water particles. The pressure will generate. Another another point is the due to the random movement of the particles. Okay, so the water pressure is generated in two ways. First way is due to the weight of the water column. There is a force applied on the bottom of the container. So there is a pressure exerted. Another case, these particles are going to move randomly. So they are going to bump with the wall of the container, or if there are any solid particles in the container. So due to the bumping, they generate a force. So if a force exerted in the perpendicularly to the area, there will be a pressure will be generated. Are you clear? So pressure or water pressure is generated due to two reasons. First one is due to the weight of the water column, and second one is due to the random movement of the particles. Now I have a question. We all know force is a vector quantity. We all know force is a vector. Already studied. But pressure is a scalar quantity. We say pressure is a force. It's a force in an area. So then what's the difference? Why force is a vector but pressure is a scalar? It's my question. Okay. We can prove this one in two ways. First case, pressure is equal to force upon area. In normal condition, we all know force is a vector, area is a scalar. So ultimately pressure have to become as vector. But what's the difference is? Here we define the area as only the perpendicularly to the force. So we define the direction for the area in this case. So actually in this situation only the area become as vector, not scalar. It become as vector. So mathematically pressure will become as scalar. Another point we have studied. Liquid pressure acts not only in one direction, it acts in all the direction. We have studied, no? Water pressure not only acts in the downward direction, it acts in the all direction. So, we can say pressure as a scalar quantity. Okay? Pressure, you have to memorize this. Pressure is always a scalar quantity. Even force is a vector, pressure is a scalar quantity. Are you clear? Uh, the picture shows how pressure exerted, on the diver who is under the sea. Okay, you can notice these arrow points. Arrow points are in the all direction, not only in the downward direction. It's in all directions. So we can say the water pressure acts in all direction. Okay, there is no simple direction for the water pressure. So we can say pressure as a scalar quantity. Are you clear? Water pressure acts in all directions. Okay. Now we move to the characteristic of hydrostatic pressure. Okay. There are some characteristic of hydrostatic pressure we have to study. Okay. To find out these characteristics, we have to do some activities. These all activities you can done in your home easily. First activity, to find out that water pressure acts in every direction. We already said no, the water pressure acts in every direction. We have to prove that one. No, the water pressure acts in every direction. Every direction. We can't say without experiment water pressure acts in all directions. So we have to do a simple experiment for this. For these experiments, you can easily do yourself in home. Take a polythene bag, okay? Take a polythene bag and make several holes as in the figure. Make several holes as in the figure and fill with the water. Fill the polythene bag with the water and hold it as in the figure. Okay? As in the figure, you fill the polythene, hold that polythene bag and hold it in your hand. What's your observations? You can observe that water is exit through all the holes. Okay, water will exit through all the holes. That's your observation. So you can observe water will exit through all the holes. So you can conclude that the water pressure acts in every direction. That's why water will come through all the holes. Okay, water will exit through all the holes. That's the first activity. Okay, first activity, we have proved that water pressure acts in every direction. Okay, from this experiment we can conclude that the water pressure acts in every direction. That's the first characteristic of hydrostatic pressure, that is water pressure acts in every direction. Okay, second activity is to find out that water pressure at the same level of liquid is the same. Water pressure at the same level of liquid is same. We have to prove that same level of liquid, water pressure at the same level of liquid, this level, in these all, throughout this level, water pressure is same. Likewise, in all the situation, water pressure at same level always equal. So, to confirm this practical, you have to take a plastic bottle. You have to take a plastic bottle and make several holes like this. Make several holes at the same level. Okay, make several holes at the same level, and after you fill with water and observe what will happen. Okay, this experiment also you can carry yourself in your home. Okay, you can observe water will exiting the bottle through the holes. Okay, you can observe that water will exit through all the holes. But the important thing is the horizontal distance traveled by the water is equal. Okay, for a simple, if the hole we place in this point, water will come, the horizontal distance traveled by the water at the same level of water is same. From this experiment, we can conclude that the pressure at the same level of liquid is same. This throughout this all the level, the pressure is equal. Okay, that's why the horizontal distance traveled by this water is equal. So this is the second characteristic of water pressure, that is water pressure at the same level of liquid is same. Okay, and third one is the find out how the height of the water column in a vessel affect the pressure. Okay, how this height of the water column affect the pressure. To confirm that experiment, you have to take a plastic bottle and make a holes from bottom to top to bottom. Okay, make a holes, approximately equally spaced holes. Okay, you have to make holes in the wall of the bottle. Then thereafter fill with water and observe what will happen. you can observe that the horizontal distance traveled by the lower level particle is high than the upper level particle, and also the speed of the lower holes particle is greater than the upper hole water. So we can confirm that the pressure will increase with the depth of the water. Okay, by increasing the depth, pressure also increasing. So how we conclude that one? By two ways. The speed of the water exit through the lower holes. Speed of the water exit through the lower hole is greater than the upper hole speed, and also the horizontal distance traveled by the lower hole is greater than the upper holes. From these two observations, we can conclude that the pressure in liquid increases with the depth of water column. Okay. And for fourth one is the how the pressure of a liquid depend on the shape of the water column. Okay, shape of the water column. For this experiment, you have to take 5 transparent various shape tubes. Then fix them into a PVC, closed PVC. It's important. That's the closed PVC tubes, and fill it with water. You can observe the height of the liquid. This height of the liquid in each of the tube is same. Okay, height of the liquid water column in each of the tube is same. So you can conclude from this the pressure due to liquid column. Okay, pressure due to liquid column do not depend on the shape of the water column. Okay, here there are different shapes. First one is this shape, second one is this shape, but in all the cases pressure is same. So we can say the water pressure do not depend on the shape of the water column. So these are the activities we had to done to confirm the characteristic of hydrostatic pressure. Okay, now we can summarize what are the characteristic of liquid pressure. Uh, Pressure increases with the height of water column. From these, we have done 4 activities. From these 4 activities, we find out some characteristic of liquid pressure. First one is the pressure increases with the height of water column. Okay, with the height of the water column, pressure will increases. Okay. Second one is pressure at the same level of the liquid is same. Uh, in if in the same level throughout this level pressure is same. Okay, that's the second summary we have found out. Third one is at a given point in liquid pressure is act in all direction. So okay, pressure is active all direction. Pressure is acting in all directions. And fourth one we confirm is pressure does not depend on the shape of the liquid column. Okay, I clear. We have studied that's a characteristic of liquid pressure. So we have carried therefore 4 activities we have carried. Okay. Now we have summarized what we have studied today. First we have studied regarding pressure. We have studied pressure as a perpendicular force. The term perpendicular is must. There's a perpendicular force acting per unit area. We called it as pressure. Okay. The unit for the pressure is actually Newton meter minus 2. Anyhow, as a tribute to scientists, the SI unit for the pressure is Pascal. Actually, the Pascal is equal to 1 Pascal is equal to 1 Newton meter minus 2. Okay. Then thereafter we have carried some exercises, and our topic we studies that the hydrostatic pressure. Okay. The pressure is exerted by the solid substances due to the weight of that solid substances. Similar case occurs in the liquid substances also. We all know liquid substances also has weight. So, due to the weight of that water column, the pressure will be exerted in the bottom of the container. Okay, this is the one case. And another case, we have noticed that the direction of the hydraulic pressure. Actually, the hydraulic pressure do not have a single direction since the particles in the liquid substances are randomly move throughout since they are loosely connected. So, these particles are always randomly move. So, they are going to bump with the particles in the liquid substances or with the wall of the container. They are going to bump. Due to the bumping, there will be a force will be generated. Okay, that's the case. And we have studies the water pressure is exerted by two ways. Due to the first one is due to the weight of the water column, and second one is due to the random movement of the particles. Since the particles in the fluid substances not compactly bounded as solid substances, so they are going to move randomly. So they are going to bump with other particles or with the container. Now, thereafter, I ask some doubt that if a force is, even force is a scalar quantity, force is a vector quantity, then how pressure become as a scalar quantity? We have proof it in two ways, as mathematically and in scientifically we have proof. That's in the hydraulic pressure is not only at downward direction, it acts in all the directions. So, it's become as a scalar quantity. Then we have carried some activities to find out the characteristic of hydrostatic pressure. First characteristic we have studied, that is water pressure acts in every direction. Okay. To confirm this characteristic, we have carried a simple experiment. That is, we make some holes in the polythene bag and fill it with water and hold it as in the figure. So now we can observe the water is exit through all the holes in the polythene bag. From this, we can conclude that the water pressure acts in every direction. That's the first characteristic of water hydrostatic pressure. That is, water pressure acts in every direction. Are you clear? Okay. Second characteristic we have studied is the water pressure at the same level of liquid is same. Okay, same level, at the same level in each point water pressure is same. Okay, to confirm this characteristic, we take a plastic bottle and make some holes at the same level and fill it with water and observe. So now we can observe that the horizontal distance traveled by this by the water column is same for the same level liquid. So from this we can confirm that water pressure at the same level of liquid is same. Okay. So second characteristic we confirm is the water pressure at the same level of water is same. And third one is liquid pressure increases with the height of the water column. To confirm this experiments, we take a plastic bottle and approximately equally spaced holes are made. Thereafter, fill with water and observe. Now we will observe as the horizontal distance traveled by the lower part of the hole is higher than the upper hose, and also speed of the water exit from the lower hole is speed of the water from the lower holes is greater than the upper holes. So from this observation we can confirm the water pressure increases with the depth of the water column. Okay, and fourth one we confirm is the liquid pressure do not depend on the shape of the container. Okay, the water pressure in each conditions, the water level is same. So from this observation, we can confirm that the water pressure do not depend on the shape of the liquid column. Okay, these are the important facts we have studied, that the pressure is a scalar quantity. Hydraulic pressure is generated in two ways, due to the weight of the water column, and second one is the due to the random movement of the fluid particles. So in two ways liquid pressure is generated. Thereafter we have studied the characteristic of liquid pressure. Okay, liquid pressure increases with the height of the water column. Okay, liquid pressure increases with the height of the water column, and pressure at the same level of the water column is equal, same. Okay, and third one we have studied is at a given point liquid pressure is same in all directions. Okay, and fourth one we have studied pressure does not depend on the shape of the liquid column. Okay, these are the facts we have studied. That the what is hydraulic pressure and why hydraulic pressure is created, and characteristic of liquid pressure we have studied. Okay, in next class we will study how this hydraulic pressure transmitted throughout the liquid column, and also the pressure generated by gases. We have to study it in next class. Okay, thank you.